In this problem we have a board that's lying across a fulcrum here, and it rests on a scale on one end, and there's a rope attached to the other end. So basically this rope is being pulled up, and this acts as a little lever here, and it pushes down on the scale. Now, we know the length of this board is 1.3 meters. We know the distance from the fulcrum to the rope is 0.2 meters. We know the weight of the board is 87 newtons. And we know that the force from the scale is 258 newtons. That's what the scale reads. So if the scale reads 258 newtons, that means that the scale is pushing back with a force of 258 newtons. So this force doesn't act downward because it's in equilibrium. The scale pushes it back upward with 258 newtons to keep everything in balance. That's where we get the reading from. So we have these two forces, and we have the last force is the weight, which acts directly in the center of this board. So the weight of the board acts right here. And we know that since this is 1.3 meters long, the total distance out to here is half of 1.3, which is 0.65. So now what we have to do to figure out our force of the rope, we want to figure out how much force we're pulling on the rope with to keep everything in equilibrium, like this. So to do that we use sum of the torques is equal to 0. We know a torque is equal to force times the lever arm. Okay, I'm going to define positive as that. It's a rotation positive. So I'll take each individual force, I'll look at the rope force. The force from this rope is going to make this thing turn this way, so that's a positive torque. So I take the torque from that is going to be force, Fr, times its lever arm. Its perpendicular distance away from the fulcrum, which is 0.2 meters here. 0.2 is that perpendicular distance. The next force I look at is going to be the weight of the board. And it's positive, because if we look at this, it is in the negative direction, but it's going to make it go in the positive. It's going to make this thing rotate in the positive direction, what we define as positive. So that's positive weight of the board times the lever arm. The lever arm, in this case, is going to be 0.65 minus the 0.2 here, so 0.45. And our last torque is going to be due to this force from the spring, from the scale, not spring, and it's minus because it's going to curl this in the negative direction. So it's Fs times its lever arm, this distance here, which is going to be 1.3 meters minus this 0.2 meters, so it's 1.1 meters. And this is equal to 0. So the sum of all the torques equals 0 because this is in equilibrium. So we know the weight of the board and the force of the scale, and we want to figure out the force of the rope. So we just plug in what we know. We have 0.2 Fr plus weight of the board is 87 newtons, 0.45. minus force of the scale is 258 newtons. 1.1 is equals 0. So we multiply all those together. So the force of the rope is equal to summation of these divided by 0.2. So basically we have, moving this to this side, we have 258 times 1.1. Subtract this, we have minus 87.45. And we divide off this 0.2. The force of the rope, 1.22 kilonewtons.